Hey guys, welcome back. As we head into the last part of our equations unit, the last piece we're going to look at are word problems. Always, traditionally some of the toughest uh, problems that you do in the equations unit because now we're going to rely on you reading something and having to write an equation or an expression from it. That's why you see today's aim says, how do we translate English into algebra? Meaning, if I give you a word problem, can you somehow write an equation or an expression out of it? Some people can just do this naturally. Others are going to use some of the tricks and skills that I teach you today to sort of master it maybe for the first time. Okay, so with that in mind, let's get started. There's your do now. I'm just going to skip over that. You guys worked on that already. Okay, here's some of the words that we're going to focus our attention on today. And I'm sure you've seen some of these words someplace before, whether they, excuse me, whether they've been on a poster somewhere or you listed them off with groups of kids when you were younger. But I see words like difference. I see words like decreased, less than, minus, fewer, many. These are all words that are used to describe operations that we do in math. And remember, when we say operations, we're talking about addition, subtraction, multiplication, division, squaring, square rooting. Okay? So our job today will be to find some of these words to help us write some expressions. And if when you're doing your first couple ones, you sort of feel like this person here, I get it. You know, a lot of people feel like that. In fact, I found this meme off the internet. It's so popular to sort of sit there and say how confused math problems can be. That's how people feel, and that's okay. Our goal, though, by the end of today is to make you feel less like that and a little bit more confident in your ability to be able to write an equation. Okay, so we're going to start with some expressions first and then move our way into writing equations. Now, I'll show you as we go into some of these expressions, some of the things that will help you as far as trying to figure out what's happening in the problem. Okay, so our first one says if x represents a number. So first of all, even before I read anymore, I now know that the variable in the problem is going to be x. It's some number. Write an expression that represents a number that's 10 greater than x. So it looks like for me, the word that's representing an operation here is greater than. So if something is 10 greater than x, you might also say it's 10 more than x, or to figure out that number, you would add 10 to x. So our expression simply here will just be x plus 10. Okay, so the first one, you might think that was pretty easy. All right, the second one. Okay, this time it's using n to represent the number. So when we write our expression, we're going to use n. It says write an expression that represents a number that is 5 less than n. So the number is going to be 5 less than n. Does that mean, and this is where we can kind of get into a little bit of a debate, does that mean this? Or does it mean this? Because those are different. Subtraction is not commutative, meaning you can't just switch those around and say they're the same thing. They mean entirely two different things. But let's reread the problem again and sort of try to figure out what it's saying. A number that is 5 less than n. So if something is 5 less than a number, it's lower than that number. It's less than that number by 5. So the only way we're going to find it is to take our number and subtract 5 from it. So it's not 5 minus n, it's n minus 5. So be careful. This is a popular one, and a lot of people put 5 minus n because they see that the 5 came first. It's not. It's n minus 5. Okay. Interesting. Okay. If y represents a number, write an expression that represents the sum of y and a number one more greater than y. That's a lot. So sometimes I'll even need to go back and reread it again There's a strategy. Reread it again. Well, in this case, we know that we're dealing with the variable y, so I can start off by understanding that. Write an expression that represents the sum of y. Ooh, the sum. I know that sum is addition. So I'm going to be adding something here. Let's see what I'm going to be adding. The sum of y. So y is going to be added in a number that is 1 greater than y. So a number that is 1 greater than y is y plus 1. Think about that for a second. We have a number, then a number that's 1 greater than it is y plus 1. So y plus 1. That was a tricky one. That actually even helped to put parentheses here. You don't need to, but at least it lets you know that those are the two numbers we added together. Y and a number that's 1 more than y. Okay, I have one more there. It says if n represents a number, then write an expression for a number that is twice n. So if I'm looking and I'm highlighting words that are sort of important, I think this one is twice n. There's our operation. Now, it's not as obvious as it's saying add, subtract, multiply, divide, square, square root. But twice n should mean something to you. If something is twice something else, it's double it. Think of it that way. So that would be 2 times that, or 2 multiplied by it. Now, if you're thinking, oh, maybe I thought that that was squaring it, that would be a number multiplied by itself. That wouldn't be twice a number. That would be a number multiplied by itself. That's what squaring would be. Okay, now that we've had a little practice with some expressions, let's look at some equations now. Okay, so here comes our first word problem that is going to ask us to actually solve for something. Saying, I want to know what the number is. So it says a number subtracted by 4, and the result is 9. What is the number? Well, there's a couple things I want to pick out before I even go ahead and try to solve this thing. It looks like I'm trying to find a number. That's number 1. It's subtracted by. So it's being subtracted. That's pretty obvious, but it's a subtraction sign. And the result is 9. The result is, I guess that's a different way of saying is equal to 9. Okay, so let's begin. Let's actually go ahead and do this whole thing. And as we do it, excuse me, I'm going to talk to you about some things that are necessary for this problem. First of all, we cannot write an equation until we decide what we're going to use as our variable. Now, traditionally, a lot of people like to use x, so let's use x. But we got to tell that to the reader. So we're going to do what we call a let statement. Let x equal the number. I'm just going to abbreviate here for time's sake. So x is going to be our variable, and we tell people what it is. So let x equal the number. So it says a number is subtracted by 4. So here's our number subtracted by 4, and the result is equal to 9. What is the number? So now I've written my equation. Now I'll just solve this equation, which is a pretty easy equation to solve. We get x is equal to 13. But keep in mind, the question asks what's the number, so we need what we call conclusions. Now, I'm going to use these little dots. These are sort of what they call a therefore statement. And we can say the number is 13. Now, if you're asking, do I need to have that? The answer is yes, you absolutely do. Okay. If it is a word problem like this one is, and it asks you to find the number, you need to define your variable first, and then at the end, make a conclusion about what you found. Okay, because in some problems, you're going to see that these actually represent things other than just numbers. They might represent someone's age. They might represent how much money somebody has. They might represent the number of t-shirts sold. Who knows? So it's real important that we make a conclusion. Although on day 1, These will all just be numbers. We still need to practice that. Okay, we're going to look at two more, just so we can see all different levels of difficulty in our first day. It says a number is doubled and added to 10. The result is 18. What is the number? All right, so maybe I just want to start off by going, let x equal the number. I don't always have to use x, but in this case I will. We cannot forget that first step. How can we write an equation with a variable in it if we haven't told anybody what the variable represents? All right, now let's go back and, if we need to, underline some important things in our problem. So some number, which we're going to call x, is doubled. I remember that doubled means multiplied by 2, and then it's going to get added to 10, and the result is, there's that again, 18. The thing almost writes itself. So we're doubling the number, 2x, we're adding it to 10, and it results in 18. Done. Solve this equation. X is equal to 4, but remember the question didn't say what is x, the question said what's the number. So we'll have ourselves a conclusion. The number is 4. Now, if I'm grading this thing, here's how I'm grading it. 1 point for the let statement. 1 point for the equation. 2 points for your ability to solve, and 1 point for the conclusion. So it's a total of 5 points. Imagine that you left off the let statement and you left off the conclusion. The best score you can get is a 3 out of 5. That's a 60%. That's not even passing. So don't forget those two parts. They're very important. Okay, our last one. And I show this last one because it has a phrase in there that is probably a little unique and maybe may not be familiar to some of you. So I'm going to read it to you together, and then we'll work on solving this thing. 2 times the quantity of a number added to 7 is 24. What is the number? If at any time too that it seems like a mouthful, I'll just go back and reread it to myself. And I'm going to do that in just a second, but I'm first going to not forget my let statement. Let x equal the number. Okay. 2 times. So 2 times. 2 is going to be multiplied by something. The quantity. Okay. That's the part that's kind of new to us. What the word quantity refers to as far as an operation. Quantity means, when you see this, that the next part is going to be in parentheses. That's what that means. So it's important that I told you that in case you've never seen that before. So what's about to be in parentheses? A number added to 7. Okay, is 24. So this is just working as our equal sign this time. All right, so now that we've kind of marked up our word problem part of it, let's try to write the equation. 2 times the quantity of our number plus 7 is 24. There you have it. And you're probably more familiar with it written like this, without that dot there, any multiplication sign. Now we're going to distribute to solve, distributive property here. And then we just go ahead and we solve our equation. Now for these first couple of ones, I have solved and done all the algebra for you on camera, just so you have a chance to see it. We end up with x is equal to 5, which we know is not where we're going to stop. We're then going to make a conclusion. The number is 5. Done. All right. Well, that's it for day 1. You're going to get a chance now to practice a few all on your own. Good luck.